On this video, I'm going to answer 2016 AP Calculus free response questions 4, 5, and 6. We'll start with question 4. So this is 2016 free response AB number 4. This is a differential equations question, and the problem says consider the given differential equation. So this is number 4. They give us the differential equation dy dx equals y squared over x minus 1. Now, this is what we call a differential equation in mathematics. Now, what's a differential equation? A differential equation is an equation with a derivative in it. And this equation has a derivative in it. And therefore, it's a differential equation. Now, this is a specific type of differential equation. It's a special type. It's a type we know how to solve as Calc 1 students. This is called the separable differential equation. And we'll get to that in Part C. Right now, in Part A, they don't ask us to solve this. They ask us to generate a slope field. Now, what we need to know about a differential equation is the equation tells us the slope. We do not know what our equation is. This has a solution, y equals f of x. We don't know that. We don't know what the solution is. We're going to find that in Part C, but right now we do not know the solution. What we know is if I graph this equation, which I don't know, so I can't graph it, but if I do graph it, this tells me the slope. dy dx is the slope, derivative is the slope, so this equation tells me the slope of my solution. So instead of telling me what the y value is when I plug in x, it tells me the steepness of my curve when I plug in x. And that's what a slope field is. A slope field is a picture of the solutions to a differential equation. So we can draw an axis that's not, meeting at a 30-degree angle here. So here's my y-axis, here's my x-axis, and this problem says I have points 1 and 2 labeled, and I have point 1 and 2 labeled here, and there are dots in the solution at 2, 1 and at 2, 2, and there are also dots at 0, 1 and 0, 2. All right, there's 4 points on the curve. I apologize. There are also points at 0, 0 and 0, 2. All right, so they give us this. This is what would be on your answer document, this picture right here. And what do they want me to do? They want me to draw the slope at each of these points. Now, we don't know the equation, but we know the slopes. So if it's possible to find the slopes, then I would just draw them. And it's not a hard thing to do. This is almost free points if they ask us to do a question like this. Because let's see, this point is 0, 0, right? 0, 0. Well, what do we get when we plug 0, 0 in up here? We get the slope at 0, 0. So if I plug 0 in on the top, I get, well, here, we can even write out what we're doing. We're going to find the slope. We'll write a couple of these out. We're going to find the slope when x equals 0 and y equals 0, because that's this point. So I'm going to plug that in. I get 0 on the top, 0 minus 1. So I get 0 squared, 0 minus 1, I get 0. So I would draw a little bar like this to show the grader. Right there, my slope is 0. Now let's plug in another point. dy dx. Now this point right here is x is 2, y is 0. So what would that look like? We're going to plug it in here to get the slope. So that's going to be 0 squared, and that's going to be 2 minus 1, so that's going to be 0. So we would draw a little bar like this. This is what we do in our answer document, and we say, okay, the slope right there is 0. Let's do another one. We'll do, this is x is 2, y is 1, right? This point right here. So what's my slope when x is 2 and y is 1? Well, when y is 1, we get 1 squared on the top. When x is 2, we get 2 minus 1 on the bottom. We get 1 divided by 1, we get 1. So we draw a line right here that's 45-degree angle to show everybody that the slope is 1. What's this one? Well, this is x is 2, y is 2. Let's see if we can do that one without writing it down. If x is 2, we get 2 minus 1, right? That's going to, remember, that's the point. X is 2, y is 2, right? That's the point. So 2 minus 1 is 1. 2 squared is 4, so we would draw a steeper slope here. Now, they don't expect you to get out a protractor and try to figure out the angle. They just want you to show them, well, that one was 0, that one was 1, that one was 4, 4 steepest. All right? What about this one? X is 0, y is 1, right? So y is 1, that's 1 squared is 1. X is 0, we get 1 divided by negative 1. That's going to be a slope of negative 1, so it's going to look like this. Here, x is 0, y is 2. 2 squared is 4. 0 minus 1 is negative 1, so here we get negative 4. And this is the answer. This is what our slope field looks like. What does it show us? Well, it shows us something about the solution of our graph. If we think about it, if we take a look, they're not going to ask us to do this, but I'll just show you what slope fields do. If we look, the slope of our problem is undefined at negative 1. Right? The slope is infinite at negative 1. And if we look at this, it kind of shows us how that happens. Solutions come in, they have a slope of 1 here, and they're going to go to infinity here. Here, solutions come in, they have a slope of 0, but they're going to go to infinity here. Here, solutions come in, and they go like this. So if we look at this, this is what our solutions are going to look like. When we eventually find the solution, this is what it's going to appear to do. Now, they don't ask us to draw the solutions. They just want us to draw those 6 slopes, and we get points for that. Okay, so now let's take a look at part B. That's all we have to do is part A, is draw those slopes, and we're done. That's why a slope field is a great question to have on the AP test. Part B says, y equals f of x is a solution to your differential equation. So part B says, y equals f of x is a solution. Now, what does that mean? That means y prime, right, when I take the derivative of this, or f prime, whichever way you want to say it, when I take the derivative of my solution, I'm going to get y squared over x minus 1. Right? That's what the problem says. Now, I don't know what this function is. I have no idea what it is. But it says it has an initial condition 2, 3. So it gives us what's called an initial condition. F of 2 equals 3. Now remember, that's x, that's y. So what does that mean? It means our solution goes through the point x is 2, y is 3. See, these purple solutions, these are solutions. But we're looking for the solution that goes through that point. Right? We're looking for that solution. That's the one we want. There are an infinite number of functions whose derivative turns out to be this. Okay, that's a characteristic of differential equations. There isn't one solution, there's an infinite number of solutions. One of them is this purple line, one of them is this purple line, one of them is this purple line. One of them would be a purple line going this way, one would be a purple line coming through here, one would be a purple line coming through here. There are an infinite number of solutions. They want us to find the solution that goes through the point 2, 3. Okay? They want us to find out something about that solution. And what does it say? It says, write an equation for the line tangent to that solution. So we don't know what this solution looks like, right? We do know it's infinitely steep, right? It comes through and it's infinitely steep. Now, I don't know what else it does. They want me to find the slope right there. Right? The slope right there. And based on our picture, right, based on our picture, what do we know? How are we going to find the slope? Right there. Well, we have an equation right here that tells us the slope. So we're going to find the slope by saying, well, if you want me to find the slope, I have an equation that tells me the slope. I'm going to plug in x is 2, y is 3, and what am I going to get? I'm going to get 3 squared over 2 minus 1. That's going to be 9. So right there, my slope is going to be 9, right? 9. So my red line really should be steeper because right here my slope is going to be 9. It's almost straight up and down. Now it says, find the equation of the tangent line. Well, you and I know the formula for the equation of the tangent line. And they've told us y is going to be 3. We just found out the slope is going to be 9, and we know x is going to be 2. There we go. That's the equation of our tangent line. After that, it says, use your equation to approximate f of 2.1. Okay, well, what does f of 2.1 look like? In other words, what does the y value look like when we plug in 2.1? Well, look at what they gave us here. They want to know what the y value is going to look like when we plug in 2.1. This is 9 times 0.1, right? 2.1 minus 2. So we have y minus 3 equals 0.9. We move the 3 over, and we get y equals 3.9. All right? Now, if you're thinking to yourself, that looks a lot like linear approximation, it's because that is linear approximation. This is how they asked in 2016 for us to do linear approximation. Okay, so what am I going to do now? Well, I'm going to do part C. I'm going to have to clean off some whiteboard space, so give me a second here to erase. We don't need any of this for part C. Now, part C, on a lot of AP tests, you AB kids, on a lot of your AP tests, especially if you're looking at other ones on the internet, you're going to see a lot of these differential equation problems. Part C is going to be for us to solve this. Most of the time that's part A, but this is going to be part C. Part C says find the solution that goes through that point 2, 3. Find the solution, say, find this given f of 2 equals 3. They want me to find f of x. Now, I mentioned earlier, we call this a separable differential equation. What does that mean? It means we can separate this. I can put the x's on one side, the y's on the other. I'm going to use my algebra. I'm going to put the y squared under here. I'm going to use my algebra, and I'm going to put the dx up here. That's called separating the variables. I have all the x's on the same side. I have all the y's on the same side. That's the kind of differential equation you and I can solve going into our AP test. Because what do we do to solve this? We integrate this, and we integrate this. Because we just turn them into two integrals. All right, we turn them into two integrals. Now, we can integrate these, right? We can integrate these. This is the integral of y to the negative 2 dy. We know how to integrate. You add 1, y to the negative 1. You divide by negative 1. This is a u sub. U equals x minus 1. Du equals dx. And this becomes the integral of 1 over u du. And we know that is the natural log of the absolute value of u. Now, I haven't written down the constant anywhere, so I'll put it right here, plus c. Okay, So our solution here, we'll rewrite this y to the negative 1. So this is minus 1 over y equals ln of u is x minus 1, plus c. Okay? Now, this is called our general solution. So listen carefully to what I'm about to say, please. If I graph this on my TI-89, c represents a constant. So I can graph this and let c be 1. And you push graph on your calculator, it's going to draw a graph. Then you can do it when c is 2, and c is 3, and c is 4, and c is 5, and c is 6. And you're going to get an infinite number of solutions. Because you can do it when c is negative 1, and c is pi, and c is 3/7. You can pick any value of c you want. You're going to get an infinite number of solutions. But we want the solution that goes through the point 2, 3. So how do we do that? We plug in 2, 3. If I plug 3 in here, I get ln absolute value 2 minus 1 plus c, right? X is 2. That gives me negative 1/3. This is the natural log of 1. The natural log of 1 is 0. Right? The natural log of 1 is 0. So I get negative 1/3 equals c. So I go right here to my general solution and I rewrite it. And now we know c is negative 1/3. That is called a particular solution. Now, what do we have to do to solve this? Well, we have to rewrite this by solving for y. Okay, we got to solve for y. So how are we going to solve for y? Well, this is a reciprocal, so we're going to reciprocate both sides, right? If we reciprocate both sides, this is minus y. This is 1 over ln x minus 1 minus 1/3. We have a negative here. Can we get this? Now, what do we have to do? We have to tell them, when is this a valid solution? Right? Because we can't have a 0 here. Right? We can't have a 0 here. So we would have to check to see when 1/3 minus ln x minus 1 equals 0. And we all know where that's going to happen. We're going to move the 1/3 to the other side. We're going to get ln of x minus 1 equals 1/3. Right? Negative cancels. E to this, x minus 1 equals e to the 1/3. X cannot be 1, right? Bring that over, plus e to the 1/3. Now, what else do we know? Well, if x is bigger than this, right? If x is bigger than that, then this is going to be undefined. Plus, we know x, from right here, we know x can't be 1, because we can't take the natural log of 0. So x has to be smaller than this, but bigger than 1. Okay? So that's question number 4. All right? That's question, and that's a differential equation question. And you know, we haven't done a lot of these, so every time I do one on one of these videos, my expectation is you're going to pay, he's going to say particular attention. That was a Mr. Holiday pun. You're going to pay close attention and learn how to do these. All right, so now we're done with number 4. Let's go ahead and take a look at number 5. All right. So in problem number 5, we have a funnel. All right. Now this question is also on the BC test, so I'm going to go ahead up here at the top, and I'm going to write AB and BC. Okay. So we have a funnel. Let's draw our funnel over here on the side. So they gave us a funnel, and so we have a funnel that goes like this, and it comes down like this. And what do we know? We have liquid in the funnel. All right, we have some liquid in the funnel, and the radius of our liquid is R. And the height of our liquid is H. This is what we know about our funnel. Inside the funnel, and we know our height of our funnel is 10 inches. Okay, so the height from here down, 10 inches. And the radius is given by, so they give us the radius, but they give it to us as a function. The radius is equal to 1/20th 3 plus h squared. Now here's the kicker about what just happened. This is going to be a related rates problem, right? It looks like one of those related rates problems we did back in the day. We always did problems with cones. But this is a nice related rates problem. One of the steps you and I always had to do on related rates problems is we had to write R in terms of H, or we had to write H in terms of R, because we had to write one of the variables in terms of the other variable. So we always had to know the equation of the funnel or the equation of the cone. We had that extra work we always had to do. Look, R equals 1/20th 3 plus h squared. They've already done that step for us. We don't have to do that step. Okay. Now, part A says find the average value of the radius of the funnel. In other words, in part A, they want us to find the average value of R of H. Now, we know how to find the average value of a function. The average value of a function is 1 over b minus a, the integral from a to b of R of H dH. That's our average value of a function formula. Well, we know all these things, right? This is the integral of 1 over 10 minus 0, the integral from 0 to 10 of 1/20th 3 plus h squared, dh. Now we can do this integral. We all know how to do this integral. This comes out, 1/20th comes out. There's a 10th out here, so that's 1 over 200, isn't it? This is the integral from 0 to 10. We have 3 plus h squared dh. Well, that's a very simple integral. That's 1 over 200, 3h, right? You integrate 3, you get 3h. You integrate h squared, you get h cubed over 3, between 0 and 10. So what do we get? When we plug in 0, we get 0. So when we plug in 10, we get 1 over 200. 3 times 10 is 30. 10 cubed is 1,000 over 3, right? Minus, we got to plug in 0. When we plug in 0, we get 3 times 0, that's 0, plus 0 cubed over 3 is 0. And then we do our arithmetic and find our common denominator, and we get 109 over 60. Right, I'm not going to do the elementary school arithmetic. Now, they wanted the average value of of the radius, so that's 109 over 60 inches, right? Because those are the units. So that's just, I scared you, making you think it was a related rates problem. It looks like it is, and I turned it into an average value of a function problem. You shouldn't have been scared at all. Okay, you got 3 points for doing that. So 3 points if you remembered the formula and got the numbers right. Now part C says find the volume of the funnel. All right, find the volume of the funnel. So how are we going to find the volume of the funnel? Well, we know how to find the volume of the funnel because the funnel, if we look up above, we see where it tells us in the problem, right? It tells us the inside of a funnel of height 10 inches has circular cross sections. These are circles. So we're going to add together a bunch of circles. Well, we know the area of the circle. The area of the circle is pi r squared. Here's r right here. So to do part B, we just got to add up all the circles. There's one there. There's one there. There's one there. We know how to add up things like this. That's what an integral does. So to find the volume, right, we need this formula. So our volume is going to be the integral from 0 to 10 of this, pi times r squared. And r is 1 over 20 times 3 plus h squared dh. Okay. And what does that equal? Well, 1 over 20 squared is 1 over 400. There's a pi. So that's going to be pi over 400, the integral from 0 to 10, of 3 plus h squared dh. Now I got to expand that because I can't do a u sub here, so I'm going to expand that. That's pi over 400, the integral from 0 to 10, of 9 plus 6h squared plus h to the 4th dh. Now when we integrate that, what do we get? We get pi over 400, 9h, 6h cubed over 3, plus h to the 5th over 5, and we're evaluating between 0 and 10. Okay. Now, I'm not going to do all the arithmetic here. I'm just going to write down the answer. You all can plug a 10 in here and get common denominators. So if you solve this, right, if you solve this, you get 2209 pi over 40. Square inches? No. Cubic inches, because they asked us for the volume. Now, what about part 3? Well, here it is. Part 3 is the related rates problem. Okay, we knew there was going to be, it looked like a related rates problem, we wrote it down, but look what they did, right? For you AB kids, this volume question wouldn't be on your test this year. But why did I do it? I did it because it's also a BC question, so I wanted it to be there for the BC kids. So look what they did. This is what they're going to do to you this year. They have one question. One question. They've asked you average value of a function. They've asked you to do a volume calculation. And now in part C, they're going to ask you to do related rates. That's what's going to happen on May 12th. One question, lots of different ideas built into that one question. This is the closest thing I've seen since we've been reviewing that looks like something I could say, this looks like something to be on the AP test this year. So what do they want us to do in part C? Well, in part C, and let me erase some of this. We'll go ahead and leave our picture of our cone up here just in case we need that. We'll leave that up. We don't need the average value of the function. So get rid of all of this. So what do they ask us in part C? The funnel contains liquid that's draining from the bottom. At the instant when the height is 3, the radius is decreasing. So when, this is part C, when h equals 3, the radius is decreasing. That's a derivative, right? The radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. Decreasing. Right? Decreasing at a rate of 1/5 inch per second. At this instant, what's the rate of change of the height with respect to time? Rate of change of height that's a derivative, right? That's a derivative. Rate of change. They want us to find dH/dt. Now, how are we going to find that? Well, we're going to take the derivative of this. If I take the derivative of this side, I get dr/dt. I know what that is. If I take the derivative of this side, I get 1/20 times the derivative of this. The derivative of 3 is 0. The derivative of h squared is 2h dH dt. This is what they want me to find. But we know all these numbers. We know dr/dt is negative 1/5. We know that's 1/20. We know that's 2. They told us while this is going on, h is 3, and they want us to find dH/dt. So what do? Well, what do you think we do? We put the 20 up here, and we put the 2 in, put the 6 down here. So we have minus 20, right? That goes up because it's a denominator. Over here, so it's a numerator over there. So this is going to be 5 times 2 times 3. 5 times 2 is 10. So that goes into here and gives me a 2. And we get dH/dt equals negative 2/3 inches per second. There you go. One problem, 3 topics. All right? So that's question number 5. Now, question number 6 is just going to be an A-B question. So you BC kids, you can stick around to see how to do this question, even though it's not on your test. Or you can, exit out of this video and go back to the BC video at this point. All right, so I'm going to erase this. Now we'll do question number 6. All right, question number 6 is one of those problems where instead of a function, they give us a table of values. All right, these are very common on the AP test. We all know how to take the derivative if we have a function. We all know how to integrate if we have a function. We all know how to find the max and the min if we have a function. Functions are nice. So what do? They want to know if we still understand how to do that. So they take those away and they give us a table of values. So it says the functions f and g have continuous second derivatives. So this is number 6. Continuous second derivatives. And what does that mean? It means the second derivatives exist. Well, if the second derivatives exist and are continuous, then the first derivatives are continuous. And if the first derivative is continuous, the functions are continuous. So what this means is f and g are continuous. And of course, differentiable we know they're differentiable because they both have a second derivative. So we got the first derivative and the second derivative. The table above gives values of the functions and the derivatives at selected values of x. So then it goes on and part A says Okay, part A says, now they're just going to try to confuse you with notation here. That's all this is. So keep your head on straight, everything's going to be fine. K of x equals f of g of x. Okay, this is K of x. They want the equation of the tangent line, right? When it's when x equals 3. Now you all know what this is. The equation of the tangent line looks like this. That's the equation of the tangent line. And you know what f of 3 is. According to the table, f of 3 is 8. So this is y minus 8 equals f prime of 3 times x minus 3. That's not good enough, though. We need the derivative of f at 3. Oh, I am so sorry. We're finding the... I'm going to erase all this because it's wrong. I misread the problem. I'm so sorry. They want us to find the equation of the tangent line of k. So the equation of the tangent line of k is y minus k of 3 equals k prime of 3 times x minus 3. Okay. Well, you look up above and you think to yourself, they didn't tell me k. I don't know k of 3. Yes, you do right here. K of 3 is f of g of 3. And you know from the table that g of 3 is 6. I just looked that up on the table. G of 3 is 6. It says on my table, g of 3 is 6. But g of 3 means this, because it's a composition, becomes f of 6. And my table tells me f of 6 is 4. So this is now y minus 4. Now I need k prime of 3. And if you're thinking to yourself, I don't know the derivative of k. Yes, you do. K is this. You know k prime is equal, you know the chain rule, it's the derivative of the outside function at the inside function times the derivative of the inside function. See what they're doing here? They're just seeing if you know the chain rule. So what's k prime of 3? Well, that's going to be f prime evaluated at g of 3 times g prime at 3. And we can look all those up. We know g of 3 is 6. So that's f prime of 6. We know g prime of 3, if we look at the table, g prime of 3 is 2. And now we go back to our table and we find f prime of 6 is 5. And now we plug it in. There you go, part A. Okay, that's part A. Part B says, oh, that was fun. You did it with a composition. I wonder if you can do it. I wonder if you can do it with a quotient. That's all part B is. Look at part B. They give us a new function, h. H is g over f. And it says, find h prime of 1. Well, what's h prime equal? Well, you know the quotient rule as well as I do. It's denominator, derivative of the numerator, minus numerator, derivative of the denominator, all divided by denominator squared. Now plug in 1. What's f of 1? F of 1 is negative 6. What's g prime of 1? G prime of 1 is 8. What's g of 1? G of 1 is 2. What's f prime of 1? F prime of 1 is 3. We said f was negative 6. So what do we get here? We get negative 48 minus 6 divided by 36. Or negative 54 over 36. And that's, what goes into 54 and 36? 9? 9 goes into 54 6 times. 9 goes into 36 4 times. There we go. And what about part C, right? What about part C? What do they want us to do in part C? Let me see if I can read it here. Part C says, I'm going to have to erase our purple stuff up here. Hang on just a second. Make some room for part C. So this is kind of a fun question here. All right, so what does part C say? Part C says find the integral from 1 to 3 of f double prime of 2x dx. All right, integral from 1 to 3 of f double prime of 2x dx. Oh, man, I don't know f. I don't know f prime, I don't know f double prime, but I know the fundamental theorem of calculus. And this, right, if I integrate this, what do I get? Well, if I integrate f double prime, I get f prime. Right? Don't I get f prime? That's what happens, yes. But I've got to do a u sub here, because that's a 2x. So this isn't my answer, right? This isn't my answer. That's how I'm going to do it, right? I'm going to come over here and I'm going to go u equals 2x, du equals 2dx, and we're going to go, oh, I need a 2 in front of this. Okay, I can get a 2 in front of this. I'll put a 1/2 right there. Now look what you got. 1/2 the integral. I'm not going to put the bounds because I'm about to make this a u integral. F double prime of u du, which is 1/2. The integral of f double prime is f prime of u du. Oh, no, tu, I apologize. That's gone because we integrated. Right? So what do we have? Well, we put back in u, we get 1/2 f prime of 2x. And now that x is back, our bounds come back. And our bounds come back. So what does this equal when we get all done? Well, I don't know. It looks like to me it's going to be 1/2 times f prime, 2 times 3 is 6, minus 1 times 2. And you know what? Both those are in our table. I'll have to go back up to the top of the page to the table. F prime of 6 is 5. F prime of 2 is negative 2. Seven F's. All right. So that's the answers to questions 4, 5, 6 from Free Response 2016 AB exam. All right. Keep working.